and quartile 3. So we always start with quartile 2, and you can see that in video lecture because quartile 2 it's a median. So if I looked quartile 2, it's going to be on 62 because here I will have how many? 1, 2, 3, 4, 5, 6, 7, 6, 7. Okay, 7 and 7. So in this case, our quartile 2 is going to be 62. Now, next we need to find the first quartile. So how many we have here? Or you can do third quartile, it doesn't matter. So we have 1, 2, 3, 4, 5, 6, 7. So which means this one, it's going to be, since there are 7, so it's going to be 58. And the same way, if you go through the third upper part of this data, it's going to be 1, 2, 3, 1, 2, 3. So 64. Okay, B, interquartile range. We need to find interquartile. Interquartile is Q2 minus Q1, which is going to be, Q3, I'm sorry. It's going to be Q3 minus Q1. It's going to be 64 minus 58. And result is going to be 6. And lastly, is there any outlier? So if I look at the data, look here, I'm going from 54, 55, 56. So it's there is no big distance between number, but here 65 and then jumping to 80. So to understand what outlier is, please go to video. Outlier is the one that's standing far away from this set of numbers. So 80 is far away from 65, right? So outlier is going to be here 80. Okay. Question number 3. Use the box and whisker plot to identify the 5-number summary. Okay, this is our minimum, which is going to be 11. This is our quartile 1, which is going to be 12. This is our quartile 2, which is going to be 15. Quartile 3, which is going to be 17. And whisker, it's going to be 20. Okay, that was easy question. Let's move to question number 4. All right, so now we have the opposite situation. A database is given. Boxplot is given. We need to write down ourselves how much is the minimum, maximum, first quartile, second quartile, and third quartile. So first of all, we need to arrange the data in ascending order. It's pain for me to do manually because I always flip in Excel and it's not convenient now to draw in Excel. Although I can, I believe I saved question number 4. Let me check real quick in Excel because when I was solving, I did it. I used Excel. 1 second, I will tell you. Okay. No, I have 7 and 9 saved, not 4. Well, that's okay. I'll do it here. I'll do it here. So the smallest number we have 2, and 2 of them 2. Let me write down. I'll put it here. So to have space. 2, 2, and then, oh, another 2. And then 4. After 4 comes 5. And then 6. 1, 2, 3. 1, 2, 3. 7. 1, 2, 3. 1, 2, 3. 8. 1, 2, 3, 4. Great. 1, 2, 3, 4. And 9, I have 1, 2, 3, 4, 5. Oops. 5 of them. 1, 2, 3, 4, 5. How many we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Do we have the same thing? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, very good. Now, I'm going to find the minimum, which is clear. It's going to be 2. Maximum, it's also clear. It's going to be 9. Let's go through quartile 2 first. Since we have 20, so position 10 and 11 is going to be our mid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 10 and 11. 7 and 8, right? 10 and 11 positions. So it's going to be, in that case, it's going to be 7 plus 8 and divide by 2. So it's 7.5. So it's going to be 7.5. Which is going to come here. But it looks like 7 here. Let me see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.5. Yeah, it looks like 7.5. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7.5. All right. Now quartile 1 is going to be. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 5 and 6 positions. 1, 2, 3, 4, 5 and 6 positions. It's going to be 5 plus 6 over 2. It's going to be 5.5. Which is going to be this one. 5.5. And the quartile 3, it's going to be 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4 and 5th position. 1, 2, 3, 4. This position is going to be 9. Okay. So we got it. This is 7.5. This is 5.5. Minimum comes 2. And maximum comes 9. Okay, we are good. Moving to question number 5. Sorry, took quite a time. So question number 5. So looking at the box whisker plot, we need to determine the shape. Is it skewed Is it skewed to the right or left, or it's symmetric? From what I see, it is symmetric because this Q2, which is 80, going right in the middle. If it would be skewed to the left, then the mean would go to the left. If it would be to the right, mean would go to the right. Again, open your video lecture. So, symmetric. Question number 6. All right, again data, we need to arrange. Great. So, please make me favor, put everything, put this data in the column or in the arrow, and then click on sort out. So first you have to, you will find it on the home page when you click on the left side. Maybe I'll put an Excel and show you where you click it, okay? And put under this video. Okay. So the same way you arrange it and you can find it. So looking from this box and plot, I can say that Q2 is gonna be 3. Here it's gonna be 1. And this one, it's gonna be, this is 7, 8, so it looks like it's gonna be 6.5. So this data I'm taking from Boxplot, but this data you will get if you put in ascending order this database. You have to put in ascending order, and the same way I took care of it in this problem, like in this one. You arrange in ascending order and go through Q1, Q2, and Q3. Okay? Question number 7. So what do we have in question number 7 and how we're going to solve it? So the data show the number of hours spent studying per day by sample of 28 students. Use the box and whisker plot below to answer A, B, and C. Okay. It says about 75% of the students studied no more than how many hours per day. What do you have to do? You need to arrange in ascending order, like here you have 2 zeros, 0, 0, and then 1, 1, 1, and so on. 75%, it's a third quartile. So first quartile, it's 25%. Second quartile is 50%. And third quartile is 75%. So if you find third quartile, it should be 7. So if you won't find it, you won't get that 7, contact me obviously. Oh, actually number 7 I have on Excel spreadsheet. I will post it in ascending order. Question B. What percent of the students studied more than 5 hours per day? More than 5 hours per day. Now, 5 is gonna be, 1 second, question number 7. I'm opening my Excel spreadsheet and I will show you. Because we don't have in the database 5, it goes from 4 to 6, and 6 total we have 28 elements here, and 4 and 6 is Q2, meaning our median. It's a Q2, 4 and 6, which makes 50%. Remember, here I marked down. Therefore, since if it's asking more than 5, so it's going to go 6, 7, and it's going to be 50%. More than, therefore, the answer will be more than 50%. Because, one more time, total 28 elements, right? And the middle two position, 14, 15 position, it's our Q2, right? And it's there 4 and 6 if you arrange in ascending order. 4 and 6, and it's asking more than 5. So after 4 and 6, it's coming higher than 6. 6, 7, 8, 9, 11, which means it's going to be more than 50% because 5 falling where 50% is. That's how you find out. And I will put on the video also on the Excel spreadsheet. And C, we randomly select one student from the sample. What is the likelihood that student studies less than 2.5 hours per day? Less than 2.5 hours per day. Again, this question, it's the best to see on Excel because 2.5 hours, it's falling, 2.5 hours falling between position 7, 8, 8. This is where Q1 is. 7 and 8, it's in position 7 and 8, where is 2 and 3. 2 hours and 3 hours. And that's a Q1, which is 25. Therefore, when it's asking less than, student less than 2.5 hours, so it's going to be 25%, right? It's going to be 25%, which is, again, I will show you on Excel. I will make video on Excel and show you. Okay, question number 8. The data set below represent the ages of 36 executives. So we have total 36 executives. Find the percentile that corresponds to an age of 33. Okay, so the percentile of X is equal number of data entries less than X okay, divided by total number of entries. And times 100. Okay, so which means percentile of 33 is equal number of data entries less than X. So our X is 33, which is right here. And because we have it in arranging order, it makes our life easier. So how many we have before 33? We have 1, 2, 3, 4. So it's going to be 4 divided by total amount, 36. Let me write nicely this 4. 4 divided by 36. Okay. And multiply by 100. So we are going to get 11, which means the age of 33 years old is 11%. The age of 33 years old is 11%. Okay. All right. Question number 9. The data set below represent the age of 30 executives. So total we have here 30. Which ages are above 75 percentile? Above 70 the percentile. So we write down the percentile of X is greater than 75%. So again, the formula is going to be percentile of X is equal amount of data entries less than X divided by total amount of entries and times 100. All right. So what do we have? Percentile of X, 75. So we need to find the value of set data above 75. So first we need to find less than 75 because we're going to find out less than 75, which is going to be amount of data entries okay, divided by total amount we have 30 and times 100. Yes? Okay, now let's solve it. So what do we get? Since considering this is equation, so bring to common denominator. So common denominator is 30, which means here I divide by 30 and multiply by 30, right? All right, so then I can drop this 30 and I will get 30 times 75 is equal amount of the data entries. Obviously that is less than X, less than 75% data entries, which is times 100. Okay, so from here I need to divide this by 100 because I need only amount of data entries, right? So I need to divide by 100 here and divide by 100 here. So what am I going to get? I'm going to get, so this 100 and this 100 is gone. Here I will get 2,250 divided by 100 is equal amount of data entries. Yes? And once I divide by 100, I will get 22.5 is amount of data entries. Now, what does that mean, 22.5? That's mean 22.5, that's mean between 22 and 23 positions. Between 22 and 23 positions. So let's see, position 22, how much is it? So which value is that? So where is it? We have total how many? Total we have 30, right? 30, so I'm going backwards at the 30, 29, 28, 27. Actually, if it's 30, so there are 3, so it's starting with 20, 21, 22, right? So 22 position is 49. Let me write down. 22nd position is 49. And 23 position is 45. It's not arranged here. We need to arrange it. So you have to arrange this data. Once you arrange, you find out which position will be 22nd one and which position will be 23rd one. Okay? So since 22nd and 23rd positions, it's going to be 75 percentile, right? So 75 percentile, it's going to be, if they are going to be the same number, then it's going to be the 75th percentile. If two different numbers, let's say if both of them I get, I don't know, 45, then a 75th percentile, it's going to be 45. But if I get, let's say, 22nd position will be 45, and 23rd position will be 50, then you will get their average, which means will be 45 plus 50 divided by 2. Okay? Now, don't take these numbers literally, because I don't know what position it's going to be, 22nd and 23rd. And I can't take it right now because it's not ordered. You have to put in order, in ascending order, and then take position. Okay? 22nd position and 23rd position, because we get 22.5. And that will be your 75 percentile. Okay? We good? Question number 10. If you have questions regarding this, contact me, please. Question number 10. The midpoint the A, B, and C are marked on the histogram. Match them to the indicated scores. Which score, if any, would be considered unusual? So let's see, mark down. This is A, this is B, and this is C. All right. So we are given, let me, yeah, this is also there. We are given 3 z-scores. One is -1, one is negative 1.44, the other one is 0, third one 2.11. We need to figure out which z-score will match the point A, the point B, and the point C. The thing is, z-score in the middle, since it's bell-shaped, symmetric histogram, in the middle, the score always gonna be 0. We have here 63, which means for x is equal, here it is. For x is equal 63, z-score is equal 0. Why? Because you are right in the middle. That means this is a mean, this is median, this is mode. So it's equal 0, which means for point B, it's gonna be 0. Next, for point A, below 0 to the left of 0, z-score is usually negative. So I would recommend to read the video, watch the video lecture to understand. It's negative, which means which one we have to the left, point A here, right? Which means A is going to be negative 1.44, and B is positive, C is positive because it's to the right, and we are going to get 2.11. Why is that? Because if this is 0, on this side is negative, on this side is positive, right? Okay. And the question number, if the question B, which scores, if any, would be considered unusual? 2.11. The score 2.11 is considered unusual because the score between -2 up to +2 is considered usual. And again, you will see in your video lecture this information. Okay, moving to question number 11. The ages of the winners of a cycling tournament are approximately bell-shaped. Bell-shaped meaning like this, symmetric. The mean age is 28.4 years. Mean age, mu, is 28.4. This is mu, we read as a mu, and it's average, mean age. With the standard deviation 3.6, this is standard deviation, sigma 3.6. And the winner in one recent years was 32 years old. That's our x. To understand what is what, you need to watch the video. Okay, we need to transform these to z-score. The formula for z-score is x is equal, z. Z-score is equal x minus mu divided by sigma. So from here will be my x is 32 minus mu 28.4 divided by 3.6, and that is going to be equal 3.2 minus 28.6, it's going to be 3.6 over 3.6, and this is going to be equal 1. So z-score is equal 1. Okay, question B, interpret the result. So an age, this one, z-score shows how many standard deviations. So if it's 1, then an age of 32 is about 1 standard deviation above the mean. Why above? Because it's positive. If it would be negative, then it would be below the mean. Okay? Now determine if this age is unusual. We determine if it's usual or unusual based on z-score. Now, if z-score is between -2 and +2 is usual, and 1 is falling in this range, right? which means no. This value is not unusual. All right? Moving to question number 12. The ages of the winner of cycling tournament are approximately bell-shaped. The mean age is 27.3 years. The mean, it's going to be mu is equal 27.3. Standard deviation 3.2. Standard deviation sigma is equal 3.2. And the winner in one recent year was 29, which is x is equal 29. All right, so z-score again is equal x minus mu divided by sigma, which means x is 29 minus 27.3. It's ugly. 20. Let me hide this. It's not supposed to be seen. I don't need this. So minus 27.3 and divided by sigma is 3.2. So what do we get? 29 minus 27.3, it's going to be equal 1.7. And if I divide by 3.2, it's going to be 0.53. This is our z-score. Okay. Question number C. Interpret the result. So an age of the 29 is about how many standard deviations? 0.53. Standard deviation, it's going to be above or below mean. Remember, if the standard deviation is negative, then it's going to be below mean. If it's positive, then it's going to go above mean, above average. Please watch the video so you can understand all this. Okay, determine if it's unusual. Of course it's not. We have 0.53, right? 0.53, it's falling in this range between -2 and +2. Therefore, it's not unusual. Okay, question number 13, that's again similar one. So, mean mu is 28.1. Standard deviation is 3.2. And x is 34. All right, so z-score is equal, right down here. I'm not writing formula anymore because we have it here, x minus mu. So x is 34, minus mu is 28.1, and divided by sigma. If you calculate all this, you get 1.84. And an age of 34 is about 1.84 standard deviation above the mean. And it's not unusual because 1.84 falling in this range. Question number 14. The table shows population statistics. It shows here average age for best actors, a standard deviation for best actor, and average age for best supporting actor, and standard deviation for best supporting actor. We need to find in particular year the best actor was 42 years old, and the best supporting actor was 67 years old. We need to find the score for each. For the best actor, it's gonna be the best actor X is 42, right? So it's 42 years old. So 42 minus mu is 45, right here, and divided by 6.8. That is going to be negative 0.44. See, negative, which is below average, which is going to be negative standard deviation. And Z score for best supporting actor, X is 67, which Z score is going to be equal 67 minus mu is 51 and divided by 15. We take data from this best supporting actor, right? And this is going to be equal 1.07. Okay, round decimal as needed. Okay, we will round it. So let's do interpretation of Z score. What do we get? What these numbers, negative 0.44 and positive 1.07 tell us? So the best actor was less than 1 because we have negative 0.44. This is less than 1 standard deviation, right? Was negative 0.44. That is less than 1 standard deviation, STD, standard deviation. STD we put as a standard deviation. Below the mean, it's below, right? It goes below because it's negative. And the best supporting actor was how much? 1.07, which is above 1 standard deviation, STD, above the mean. Above the mean, which means, are they unusual? No, because the usual is negative 2 up to positive 2. Behind, less than negative 2, above 2, it's going to be unusual because both of them, negative 0.44 and 1.07, fit in this range. Then neither of their age is unusual. All right. Question number 15. The measure of position called the mid-quartile of a data set, and it's found using formula Q1 plus Q3 over 2. Find the mid-quartile of the given data set. Again, we need to arrange in ascending order. Since this is a small data set, I can do it right here. It will be 3. It's going to be next 4, 5, 6. Oh, another 5. Hold on. One more 5. And then 6. And then we get 7. Twice 9. And then 10 and 12. Let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, the best way to do it, it's enter the data set in the Excel spreadsheet and arrange in ascending order, which I will do it right after this. I will record on Excel spreadsheet real quick. It's less than 5 minutes, 2 minutes, and put under this video. You can, in the comment, I will pin the Excel so you will know, or put the link to Excel spreadsheet. All right, so mid quartile, we need to find Q1 and we need to find Q3. So to find Q1, Q3, we said we had 10, 2, 4, 6, 8, 10, which means quartile, we need to find Q2 first, which is gonna be 1, 2, 3, 4, 5, 6, and 7. Oops. So 6 plus 7 divided by 2, gonna be 13, right? And then we need to find first quartile. So from here, first quartile is gonna be 5, right? And for at the first quartile, 1, 2, 3, 4, 5, it's gonna be 9, right? Okay, which means mid quartile, it's gonna be equal 5 plus 9 divided by 2, and that's going to be 7. So mid quartile will be equal 7. Okay, moving to question number 16. A modified box plot, box and whisker plot, is a box and whisker plot that uses symbol to identify outlier. The horizontal line of modified box and whisker plot extend far minimum. Okay, let me draw it. This is our box plot with median. This is minimum. This is max. This is Q2, Q1, and Q3. So this is our box plot. To get familiar, then you are going to, you need to learn, watch the video. So first, it wants to, here is database that describe this box and plot. It's asking, are there any outliers? Let me see. Which one we can have outliers if I arrange in ascending order? So let me arrange it in ascending order. It's gonna be 1, next number, it's gonna be what? 1, looks like 8, 2 8s. Then it's gonna be what? 11, no, 10, and then 11, 11, and then twice 12, and then twice 13, no, 3 times actually, 3 times 13. What else do we have? Twice 15 and 26. Which ones look outlier? I would say 1 is this one, because look, from 1 is jumping to 8. That one is outlier, and then 26 also outlier, from jumping from 15 to 26. Therefore, outlier is going to be 1 and 26. Accordingly, I would say this is outlier, showing this would be 1, this would be 26 on box plot. Okay, actually here it is, outlier. It's showing this is 1 and this is 26. This is our outliers. All right. And if I go down, indeed, this is gonna be 1, and this is gonna be just about 26, because this is 20 and 36. In the middle will be 25, so 26. Okay. And the last question, question number 17. So what do we have here? A modified box and whisker plot is a box whisker plot that uses symbols to identify outlier. Okay, it's the same thing, we read it. Now, we need to identify possible outliers here. Let's look at the data, what we can say. I can see even without the ranging, this one is going to be free outlier, right? One is going to be free, because after free is coming what? 27, definitely outlier. And the other one, it has to be maximum to be outlier. Maximum it's going to be, what do we have here? Definitely 95. Before 95 is 71, so it's a big difference, while others have a shorter distance between each other. So it's going to be 95. And if we build a box and whisker plot, to build it, this is going to be your Q1. You need to find out Q1. This is Q2. This is Q3. And this is your outlier. This is free. This is your 95. Okay? All right. That's all. And I'll place the link in the comments. The link to the Excel, how to arrange the database, and how to find the mean, median, okay, to make it easy. All right, thank you for watching. See you next time.